if I was a seriously mad scientist, then I would really be angry, upset, disgruntled, and all that. But no, I'm not that kind of mad scientist. I'm a crazy mad scientist, and you're about to see how crazy I can get.
You like crazy.
But I have 3 favors to ask you guys, okay? Favor number 1, you guys are doing fantastic at it right now. Favor number 1 is that when I'm speaking, you guys aren't, because if you guys are talking when I'm talking, somebody misses out on what I'm doing up here. Probably the person you're talking to, and you, okay? So you don't want to do that. You don't want to miss out, okay? So favor number 1, no talking when I'm talking, unless I give you the, we're gonna have times where we can shout out answers and we can make some noise and stuff, so don't worry, okay? I know this is a library, but don't worry, you're gonna make some noise, okay? Favor number 2, I do use volunteers, okay? And I pick my volunteers by those sitting nice and quietly. If you're jumping up and down going, it's probably not gonna be you. Hold that up, Gabriella. Okay, by both ends. Cool. Now, you know why we call this a rope trick? Because we use a piece of rope. And a piece of rope has 2 ends. One over here, one over there. And if we put the 2 ends together, just like that, down here, that leaves the middle. Middle. Right, okay. So if we take that middle from down here and we bring it right up to the top up here, just like this. We take that middle right up to the top, just like that. And I had a pair, there they are. I had a pair of scissors here somewhere. Gabriella, take those scissors, open them up really wide, and I want you to cut right. I never could say scissors. Take those scissors, cut right in there. Make sure, good, perfect. Just like that, we now have 2 pieces of rope that are cut exactly the same. Exactly the same. No, not exactly the same size. First time on stage? Ooh, you should have said yes, then I could have said you had stage fright. Tell you what, I want you to take that and trim that end off right there. So you might have to open them up wider than that. You might have to open them up wider than that. Perfect, just like that. So now we have 2 pieces of rope that are cut exactly. It's okay. Just tired. Try it up right here like this. Gabriella, are you ready? We're going to start all over again, okay?
Come on!
We're going to do a rope trick. Gabriella and I would like to do a rope trick for you. We have a rope that has 2 ends. One over here, and uh-oh.
And on.
2 ends down there. That's 2 ends too many, Gabriella.
4.
Now, yeah, right, it's 2 too many. Right? 2 too many plus 2 here. Hold that end. She's got me confused now. Hold on tight. Hold on really tight, because if you see these 2 ends right here, we're just going to get rid of those. Just like that. Hold the bottom of the cup. Perfect. With both hands. Both hands, because you definitely don't want this to move. Okay, we're going to take this one, we're going to put this one over here, we're going to put this one over here. Reach up, hold on with both hands. Remember a little while ago, I said somebody in the front row was going to get wet? We're going to take a little dihydrogen monoxide. H2O. Water, right. And we're going to put a little bit of, hold it up nice and straight. Okay, again, don't move. You can't move.
Fake her first.
Stand up straight. Wait a minute, I have to move you. Because now we got to mix you up, because now everybody knows where the water went. So let's see, you go over here. You come over here. You come over here like this. Whoa, What was that? That's right. I'll put that on the table and we'll get it back to. Hold on to that cup with 2 hands. Hold on with 2 hands. Come on over here like this. Come on over here like this. Come over here just like this. Come back over here like this. Come back over here like this. Come right over here. All the way over this way. Just like that. Go over here. Go over here like this. Go over here like this. And perfect. Now I got everything all mixed up. No?
No.
Tip the cup? Shh. All right. Well, since you want to tip it, let's see. Like, you can put your hands down. It's gonna get wet. No, you didn't get wet.
He's gonna get wet. Nope.
Oh no!
Oh, she's the one.
Didn't get wet either. You might want to take a step over here. You might want to go over that way just a little bit. Don't move. Don't look up. Did you drink the water?
No.
Did you drink the water? Did you drink the water? Oh, nobody drank the water. Ew.
Can I get ice?
It's ice? Are you sure?
Can I feel it? Ice. Ice? Somebody put ice.
It's not ice, is it?
Can we?
No. But it's also not coming out.
That is ice.
No.
No,
This was actually a chemical reaction. I put a chemical powder in the bottom of the cup called sodium polyacrylate.
What?
Wow, I said it right for the first time in 2 days. Wow. Sodium polyacrylate, yes. And that sodium polyacrylate starts out looking like a little white powder like sugar. Only when you add water to it, it absorbs the water. And it absorbs the water so that it swells up and it turns into this gel-like substance. Like this. Kind of looks almost like slime, but it's not really slime. It's just kind of jelly-like. And that sodium polyacrylate, that's something that you guys have all come in contact with before. Everybody in here has used it.
What?
Yep. It's the powder that is in diapers. And you guys all touched it.
You did too!
Yeah, but I used a clean diaper.
Your hands.
Your hands can cause sound. Very good. Very good.
Our voices.
Your voices. What? Voices, right? Good. Good. Sound waves. Ooh. But what causes a sound wave? Can you just throw something in the water and have it make a sound wave?
Yes. No, I think I know. Ocean.
The beach causes sound? Oh yeah, you can hear things at the beach. Cool. Oh well, you've got a whole bunch of different things that cause sound. What else? Oh, fantastic! She hit the nail right smack on the head. In order to make sound, something has to vibrate. On a guitar, the strings vibrate. The strings vibrate, and they make the sounds by making the air around the strings start to vibrate. When you hit a drum, the top of the drum vibrates. When you talk, you vibrate.
A tornado.
Just ask your mom and dad anytime, okay? They'll tell you that you vibrate whenever you're making noise, right? Yeah. And actually, remember favor number 1, please, okay? Okay? Cool. Now, and actually, in order to vibrate, you have to start it moving. You have to start it moving. So air, does air make sound by itself? No. Can sounds travel through air?
Yes.
Can sounds travel through water?
Yes.
Can sound travel through a wall?
No.
Whoa. How many of you have ever taken a glass, put the glass or a cup up against the wall, put your ear against it and listen to what's going on in the other room?
Oh yeah. Actually, sometimes.
Yeah. Brothers and sisters do that all the time, I know. Yeah, that's cool. But you can actually hear sounds through solids, liquids, and gases. But sounds travel easier through gases and through water than they do through solids. Because the molecules in a solid don't move around too much. But the molecules in the water kind of slide by each other, which is why water is wet and moves around a lot. And then the molecules of the air, they're separated way out. They're separated way out so that, I mean, you can even walk through it and not even feel it, right? Can you feel the air?
No.
Only if you do something like this, right? So everybody do this. Everybody do this. A little more. A little more. Because it's kind of warm outside today, and I could use the air. No, just kidding. Just kidding. But okay. But you can feel the air on your hands, right? You can feel the air. That's those molecules. Now, if we get those molecules to bounce around and bounce through a tube that has a bunch of ridges on it, I gotta be careful where I'm doing this because this makes sound. If I swing it, and it makes sounds because the air going in this end is bouncing off all the ridges in here and coming out this end over here and bouncing around, making all that sound. That's the air vibrating inside the tube. And as that air vibrates into the tube, it comes out the end of the tube. Even if I go the other way. We can get sound coming out of the tube because we're making those molecules bounce around. They make them bounce around. And they travel in waves. Now, our vocal cords cause sound vibrations. Your mouth helps you to form words. But in order to be able to know what you're hearing, or what those sounds are, we need to have a receptor. And what is our receptor? The ear, right? The ear. And the ear is shaped like a shell or a funnel so that it takes those sound waves and it brings them right down in. And it puts it right inside your head. And inside the ear, right behind the eardrum, which is a little membrane that vibrates back and forth just like the head of a drum, there are 3 little tiny bones that vibrate. And they vibrate at different speeds, and they vibrate at different frequencies, which is speeds and up and down and waves and everything. All frequencies is a whole nother ball game altogether. But they vibrate around so much that they cause the ear to then send those signals to your brain, and your brain interprets the way those vibrations come in, and that's how we can tell the difference between the words. And that's why we can say, my name is Professor Presto, and you guys understand that my name is Professor Presto. Cool. Isn't that cool? Now, here's an example of how sound moves around. Would you come on up and give me a hand? Cool. And would you come? Sure. Perfect. Perfect. I have a vibration machine. Okay. Would you take and hold like about that many there and about that many there? Perfect. And we're gonna go right over here. Back up. Back up. Back up. Keep backing up. Back up. Back up. Stop. Stop. And grab on right here with 2 hands. One over here. One over here. Okay. Now. This is a vibration machine. Vibration machine. Yeah, it's a vibration machine. It's a slinky when you play with it on the stairs. Okay. But when we use it for science, we call it a vibration machine because this is going to show us how sound waves travel from the one making the sound to the one receiving the sound.
I think that's not going to work. I don't think that's going to work because it has a whole other.
Don't watch. You see, if I bring this back over here like this, hold on to it tightly. If I bring this back over here like this and then let go, now you can see the waves. And you can see the sound waves. And you can see that wave bouncing from one side to the other. It bounces all the way over here, it travels all the way over to here, bounces there, and hips back, and comes back over here, and it keeps bouncing, and that sound bounces back and forth and travels through the air, just like that. See, the bigger the wave, the louder the sound. The smaller the wave, the lower and the smoother and quieter the sound. All right, I'm going to grab this hand. I'm going to go right over here like this, because see, if I don't do this just right, what happens is gets all curled. You guys know what happens with a slinky when you let it go, right? Yeah, it goes all over the place. All right, so I'm going to just put that back on here. Cool. Thanks. You, sir.
The lightning splits the air so
Very cool. Very cool. The lightning kind of splits the air, and then as the air comes back together, it kind of makes a crashing sound. Well, what's happening is the lightning is superheating those air molecules, and they're rushing apart. And then after they rush apart, they get just so far apart, and then, boom, they come right back together, and that causes our thunder. That causes thunder. Also, in a thunderstorm, what else do you hear besides thunder? Rain. Right. We hear rain. Cool. Now, did you know that you can tell how far away the thunderstorm is by counting the seconds from the time you see the lightning to the time that you hear the thunder? Right? So if I were to simulate lightning by turning on my little lightning machine over here, camera flash. Yeah. And if I push the button, we get lightning. We get lightning. But are we going to hear thunder? No. Not unless we use a thunder machine. This thing.
Okay. It's not a thunder machine. Oh, I know that.
All right. So if we make a lightning flash and then count 5 seconds, how far away is that thunder? Or is that lightning?
5 miles.
About 5 miles, right? Because it's about 1 mile per second. Okay? So here we go. 1001, 1002, 1003, 1004, 1005, and then we... You okay? You okay? It's not real. Remember, it's not real. Okay? So, thunder and lightning travel at different speeds through the air. The light travels at one speed, the sound travels at another speed, and in all of that, we hear... rain.
I know that.
Okay? We get rain in there, right? Now, the rain stick is really cool because the rain stick is a piece of cactus. It's a piece of cactus. Now, normally, cactus has all those spikes sticking out of the side of it so that you don't want to be grabbing it on the side because it would hurt a whole lot. But what they did was they took a piece of cactus, they hollowed it out, and they plugged off the ends to make a tube out of it. Then they took all those spikes and they pushed them inside. They pushed them inside. Somebody just sat there and pushed every single spike in there so that they all kind of mixed together on the inside. And if you look inside, it kind of looks like a bunch of teeth coming together all around it and everything. And then they filled it with rice. And as your rice bounces off of those spines, we hear the rain. We hear rain. And if you do it fast, we hear a lot of rain. If you do it slow, you hear a light rain. You hear a light rain. So, now what I'd like to do is I want to create a thunderstorm up here and have some of you guys help me out. Would you come up? Come on up. Come right on over here. Would you, sir, come on up? And, yep, come on up. Perfect. All right, you're going to be the rain man. Okay, now, to do the rain, you have to do this. You have to do this. Let go for a second. You have to do this. You have to keep turning it slowly. Like that. Okay, so keep turning it. Okay. You, sir, are going to be, or lady, are going to be the thunder. I got a better job. You're going to be the lightning.
The flasher?
All you have to do is push this button. Oh, not yet! Where'd everybody go? You can only push the button when I point to you. If you push the button when I don't point to you, then I have to get somebody else. Okay? Okay. Keep it raining, and you're going to be the thunder. So what you're going to do, you are going to silently either count to 5 or 10, and then make the thunder after you see the flash. Are you ready? How many seconds was that?
3.
3. So how far away is it?
3 miles.
Cool. All right.